This is Tech. We believe technology is for everybody. Today, we're going to talk about what is an electrical engineer. So if you have career aspirations and don't know where to go, you might want to become an electrical engineer. All right, there's a lot of words. I don't want to say it, so carry it away, girl.
An electrical engineer specializes in the design, development, and maintenance of electrical systems and devices. They apply principles of electrical engineering to create solutions that address a wide range of needs, from powering homes and businesses to designing advanced electronics and communication systems.
Thank you, AI. Now let's get out of here. To become an electrical engineer, you got to go to college. And through those courseworks, you're going to have a lot of courses and classes that teach you how to become an electrical engineer. Then you get out in the field and you're not going to use 90% of it, or it'll come up every once in a while, be like, oh, I know how to do this. I learned this in college. But you got to have a fundamental understanding of electric circuits. So you have a resistor. So this is your limit of electric flow. You can think of this like in mechanical nature of like a dampeners. Or if you have a garden hose and you squeeze that garden hose, it prevents the flow of energy. Next, you have an inductor. And this stores energy in a magnetic field. Now, you can think of this like a flywheel on your engine. So you got a big giant flywheel and it moves with your engine. As it rotates, there's some momentum there and it carries it through. And when the power stops, it still wants to continue to move around and around. And then finally, you have a capacitor. So this stores energy in an electric field. So it's like a spring, a mechanical spring. You push the button on a pin, and it holds it there until you release it. So that's what a capacitor is. So every single component in engineering has an equivalent in another field, at least most of them do. Now there's also additional components, which like it's the transistor. So this is an electrical switch. Then you also have a diode. So this allows for flow only in one direction. Think of a check valve, it can only go in one direction. And then finally you'll have a transformer, which allows you to step up or step down voltages. Now, everything else is a variation of these 6 components, and these are the baselines. So when you have your processor in your computer, it is made up of a bunch of transistors, which are in themselves logic gates that do mathematical computation. So I like to divide like this industry into 3 separate fields. So first you have your construction based. So this is where you typically need a licensing. Not all electrical engineers actually need a license. It depends on your industry and where you're in. But if you're doing a lot of construction based and you have drawings, you have to stamp those drawings for regulatory agencies, you gotta have a license for that. And so I tend to think like industrial powers, controls, like for your programmable logic controllers. You have your dams, your factories, your commercial and residential construction, and oil refineries. Basically anything connected to the power grid. All of this, you're going to need a license for this eventually, or be under a person who actually has one, because they have to stamp your drawings. Now, this is one field. This is actually where I started off at Army Corps, when we did dams and stamp drawings and dams and build up programmable logic controllers to perform the actions when we push a button on a gate. So now we have electronic assemblies. Now these don't require licensing, but there's usually some sort of regulatory agency that tells you need to do a specific test or testing in order for your product to hit the market. Now that could be very, very low, like RC cars, where the only thing you have to worry about is transmission of electronics or EMI. And then usually this is like you'll take a bunch of group of components, put them together into a complex machinery, which does something big like system integration. So I think of a ship. You have all the electronics in a ship, and you don't design every single little component there. You get and you purchase those components throughout, or you might have to design your own electronics. And you can think of vehicles like Ford. So they might make their controllers, but they don't make their sensors. Vehicles, missiles, satellites. This is how most of the industry that are, I wouldn't say manufactured in the United States, but assembled in the United States work and function. You're going to grab assemblies and components from everywhere, and you build them up to make something work. Now you have your component level. So this is like your electronics, your switches, all of that. So these typically require testing and certification. So a good example of this is a circuit board. You also have integrated chips. Think of Intel or AMD. Those are electrical engineers that form how the chips are supposed to function. And then, so you take, for example, like your motherboard or any electronic component, those are individual components. So most industries, depending on where you're at, you might make your own electric circuit board, but you get your sensors from somewhere else. All right, you got all these different subfields inside of electrical engineering. So first you have your power. So this is where you make the power and you distribute it to all the buildings and everywhere. And then you have your electronics. So anything like your PC, you've got your controllers, you have anything that's ran or put on a circuit board, that's a field of electrical engineering. Then you have your telecommunications. This is your wireless communications, your RF communications, your corded communications like your phone, your telephone that nobody has anymore. All this is within the domain of electrical engineering. Then you have your computer engineering. So there's a nice little bridging over between electrical engineering, computer engineering, which is its own separate degree, and as well as software engineering. So there's kind of a little bridge and a lot of continuity between those three. Then you have your signal processing. So you think of, you send out an RF signal, you modulate it in some specific way so you can mask it. You got to be able to receive that and process it. So it's both the sending and receiving. You got your analog to digital converters. So now you have your instrumentation, and that's just sensing, sense, decide, act. Then you have your photocells and solar energy. That's a form. That's who sets up all the power grid for the solar power. You have your optics and photonics. Now there is a separate optics degree, but it all falls within the electrical engineering. So you can take in like a camera and you can convert it from a analog signal to a digital signal. And then finally you have embedded electronics. So you have your everything that has a controller inside of it in the entire world has an embedded controller into it. Now, not every electrical engineer is going to be a design and develop engineer. So there's different aspects of that, and understanding all those different aspects is something good. So you have your test and evaluation. So you do a design, you got to verify that it functions in accordance how you want it to work. You have regulatory agencies that want you to test and evaluate your hardware to make sure that it works properly. So that's one area filled. You have a project management aspect of it as well. You might work with a group of engineers where you're doing the design, but they're doing the harnessing, and so you outsource that harnessing to like somebody overseas, and they do that. So there's a project management there aspect that you going to end up doing when you're an engineer. So you also have implementation and installation. So not all this is done by technicians. I know I've done a few field trips overseas to install systems onto existing components. Why? It was low volume, and you couldn't exactly train someone to do that. So you might install and implement things. Then you have your maintenance and troubleshooting. You might end up getting in a role where all you do is maintain the existing hardware that you have and go along with that, troubleshoot when there's issues. And then finally, there's that research and development area, which I think is a crossroads between R&D and design and develop. Well, thank you for watching and joining my show. If you liked it, hit a like button, subscribe. You can even follow me on Twitter. I got a Twitter, Brunkitech, at Brunkitech at Twitter. I think it's something like that. Anyways, have an awesome day.